welcome to this particular module. So, we have seen several applications of operational amplifier to develop electronic modules, right, and those electronic modules we have been showing you different applications for industry. Now, one of the very important electronic module or the design that you need to learn is how to control a speed of a DC motor. Now, why DC motor is really important and how it will help us? You see, most of the toys in the home, like small robots, if you see at the home, a small fan working in your office, how does it work? Like a small table fan you have seen in this, or maybe the fan in the system, your computer, right? How this things works? Is there a motor required for rotating the rotor, or it rotates on some other effect? So, the point is there are several kind of motors, and starting with a static motor, we have AC, DC, and then we have different kind of sub parts where you can say is a series DC motor, it is a shunt DC motor, and then each of those have their own specific advantage, and of course there are disadvantages. For example, if you talk about series motor and you talk about shunt motor, then you will see that as the series motor can be started faster. I am talking about DC motors, okay. If it is a series motor, it speeds up rapidly, but if you keep on adding the load, then the performance goes down. But if you talk about shunt motor, then even you the starting speed, the speed is slow, but if you keep on adding the load, the performance does not degrade. So, depending on what kind of applications you are looking at, you need to select that particular type of motor, alright. So, today basically we are talking about a DC motor, and in DC motor how we can design an electronic module to control this speed. So, if you see the screen, we will start with the introduction, and I have two videos for you so that you understand what kind of how the DC motor is constructed. But if you talk about today's technology, then DC motor is extremely important, particularly from industrial component because for its efficient and effective handling of loads. DC motor is an electrical machine that converts electrical power into mechanical power, where it is used for rotating the blade, as well as the electric field generates a force in the coil that pushes the rotor. You see there is a electric field. Now you see there are two coils here, right, but and then there are static magnetic field here as at the south and north poles you can see, and then there is a electric field generated onto these particular coils. Now there is a reason why we use one coil, not only one coil but multiple coils, and you keep on increasing the number of coils, the performance of a DC motor increases. If you just use a single coil, what happens is that at a particular rotation angle, the upward and the downward moment of the magnetic field becomes cancels each other, and that is why it is a kind of a jerk. So the moment is like this, and then it is a jerk, and then it again starts. To avoid that, if we have two coils, then that can be taken care of. You will see in the video how what does that mean, but the point is the speed and direction of rotation speed depends on amount and direction of current in the supplied system, and it has several applications in the field of controlling the movement of robotic vehicles, the conveyor system used in the car tire production, movement of motors in paper mills, movement of motors in elevators, automobiles, textile industries, and so on and so forth. Thus, it is extremely important to have a precise control and accurate movement of the shaft. Shaft is you know it. However, DC motor have advantage in terms of smoothness of speed change, ease of control, and rapid dynamic response to changes in the load torque. This is a schematic where you can see that when an electrical current is passing through a coil, a magnetic field is produced, which turns the motor because of the torque generated, right. And if I show you the video, then you will understand more what exactly the DC motor is and how it works. Let me play the video.
You can find DC motors in many portable home appliances, automobiles, and types of industrial equipment. In this video, we will logically understand the operation and construction of a commercial DC motor. Let's first start with the simplest DC motor possible. It looks like this. The stator provides a constant magnetic field, and the armature, which is the rotating part, is a simple coil. The armature is connected to a DC power source through a pair of commutator rings. current flows through the coil, an electromagnetic force is induced on it according to the Lorentz law, so the coil will start to rotate. You will notice that as the coil rotates, the commutator rings connect with the power source of opposite polarity. As a result, on the left side of the coil, the electricity will always flow away, and on the right side, electricity will always flow towards. This ensures that the torque action is also in the same direction throughout the motion, so the coil will continue rotating. But if you observe the torque action on the coil closely, you will notice that when the coil is nearly perpendicular to the magnetic flux, the torque action nears zero. As a result, there will be irregular motion of the rotor if you run such a DC motor. Here is the trick to overcoming this problem. Add one more loop to the rotor, with a separate commutator pair for it. In this arrangement, when the first loop is in the vertical position, the second loop will be connected to the power source, so a motive force is always present in the system. Moreover, the more such loops, the smoother will be the motor rotation. In a practical motor, the armature loops are fitted inside slots of highly permeable steel layers. This will enhance magnetic flux interaction. Spring-loaded commutator brushes help to maintain contact with the power source. A permanent magnet stator pole is used only for very small DC motors. Most often, an electromagnet is used. The field coil of the electromagnet is powered from the same DC source. The field coils can be connected to the rotor windings in two different ways: parallel or series. The result is two different kinds of DC motor constructions, a shunt and a series motor. The series wound motor has good starting torque, but its speed drops drastically with the load. The shunt motor has a low starting torque, but it is able to run almost at a constant speed, irrespective of the load acting on the motor. Unlike the other electrical machines, DC motors exhibit a unique characteristic: the production of back EMF. A rotating loop in magnetic field will produce an EMF according to the principle of electromagnetic induction. The case of rotating armature loops is also the same. An internal EMF will be induced that opposes the applied input voltage. The back EMF reduces armature current by a large amount. Back EMF is proportional to the speed of the rotor. At the starting of the motor, back EMF is too low, thus the armature current becomes too high, leading to the burnout of the rotor. Thus, a proper starting mechanism that controls the applied input voltage is necessary in large DC motors. One of the interesting variations of the DC motor is a universal motor, which is capable to run under both AC and DC power sources. To know more about it, please check the next video. Thank you.
Okay. So, let me play another video where you will see the construction of DC motor and how it works, and in fact it is a really nice video because you can see the blown up diagram, the internal structure of the DC motor, how the coils are placed, why we cannot use a static magnet, instead of we use a electromagnet, electrostatic magnet, and how does it really help. So, let me play that video also for you.
Construction and working of DC motor. Have you ever wondered how the electric shaver works? How electric toys like small robots, toy cars, etc. work? The answer to all the above questions is DC motor. A DC motor is the device that converts DC electrical energy into mechanical energy. In order to understand the working of a DC motor, we have first explained the construction and assembly of a DC motor. Let's first understand the construction of a DC motor. Magnetic frame or yoke. This part acts as a protective cover for the machines and protects the machine from any outside disturbances. It houses field system and supports the armature through bearings. Stator magnets. They are basically electromagnets with such an arrangement so that adjacent poles have opposite polarity. They perform the function of producing the magnetic field. Armature. It is a system of conductors or coil which is free to rotate on the supported bearings. The armature consists of various parts. We will take each part one by one. To start with, we have armature core. It is made up of high permeability thin silicon content steel laminations. And the outer periphery of the core has slots to carry armature windings. Next is armature winding. It is generally made up of copper wires and is wound over the armature core. Commutator. The commutator is cylindrical in shape and is made of copper. It performs two basic functions, one being collecting the current from the armature conductor, and the other being converting the alternating current of the armature into the unidirectional current in the external circuit with the help of brushes. Brushes. They are usually made of carbon or graphite, and the main function of brushes is to collect current from moving commutator. Shaft. Shaft is a rotating part of DC motor. We obtain the final output in the form of mechanical energy from the shaft. The armature is mounted over the shaft. Now we will see the assembling of DC motor. We can now observe in the animation how this motor is practically assembled. Now, after the construction and assembling of DC motor, we will discuss the working in detail. Now, when the battery is connected to the DC motor, the current starts flowing through the armature. A force is developed in the armature due to the influence of magnetic field of the stator, whose direction is given by Fleming's left-hand rule. Now, due to the development of this force, in each armature conductor, the armature will rotate in the clockwise direction, and as a result, the shaft will also rotate. Finally, the output power in the form of mechanical energy is obtained from the shaft, which is evident from the movement of fan in the animation.
In both the videos you have seen how DC motor works, right, and how is the construction of DC motor is there. Now, let us come to our experimental part, where we will see how we can design and build a speed control of a DC motor using operation amplifier, but before that let us see why speed control of a DC motor is necessary. Alright. So, the maximum speed of the motor should not exceed the rated speed. We all know that if you have a motor and if there is a rated speed, you cannot increase the speed of a motor more than the maximum rated speed. Second thing is, manufacturing industries and automobile industries, if you see the slide, such as textile, conveyor systems, paper mills, robotic systems, require to maintain a variable rotation with load changes. That is very important. With load changes, there should be variable rotation speeds. Therefore, it is necessary to control the speed of a motor by changing the magnetic flux, and that is why we have to understand how can we control the speed of a DC motor. Now, the simplest way to control the speed of the motor is by using a variable resistor in series with a motor. However, the method dissipates energy as heat, and this method is also called armature voltage control. We will see the in experiment how we are designing this op amp based speed controller. But before that, let us understand what is the second way of controlling the speed, which is flux control. In flux control, the speed of motor is inversely proportional to the flux. Thus, by decreasing flux and speed can be increased vice versa. So, if I decrease the speed can be increased, but if I decrease the flux, speed can be increased. If I decrease the speed, flux can be increased. So, it is a vice versa, we can do that. The control of the flux rheostat is added in series with the field winding. Adding more resistance in series with the field winding will increase the speed as it decreases the flux, like I said, and so the field current is relatively small, and hence your I square R loss is small. This method is quite different, but it can control the speed above the base speed. Now, the third one is supply voltage control. If I change the supply voltage, then the speed of the DC motor can be controllable. So, now for supply voltage control, we have to use both the above mentioned methods, which is your controlling the speed of motor by using variable resistor and flux control. These are both the methods that we have discussed, cannot provide speed control in the desirable range. So, whereas the armature control method involves huge power loss, which is our first method. I said that there is a energy dissipation, excess energy as a heat, which is a power loss due to its usage of resistors in series with the armature. Therefore, a different method is often desirable. The one that controls the supply voltage to the control the motor speed is by either varying the DC voltage or pulse width modulation signal with different controllers, such as proportional controller, proportional integrator controller, proportional integrator differential methods. So, there are several methods that we can use. Now, PID is one of the most used or most preferred method in all among all three methods, which is P, PI and PID. So, PID is one of the controllers used for improving the performance of a system, including DC motor rotation control system. The speed of the response and the error steady state are the parameters measured to evaluate the performance of the proposed control system. Now, so what is the aim of our experiment? The aim is that the major task is to control and maintain the speed of the DC motor using op amp, that is our analog electronics, as per the user requirement. This requires a sensing device to measure the RPM motor. Generally, RPM is measured by using the existing encoder. So, we want to measure the speed of a DC motor, we want to control the speed of a DC motor, and to understand what is the rotations per minute, we require a encoder. However, the output of these encoders are digital. Therefore, it is necessary to design a signal conditioning circuit for the sensor to convert the frequency of pulses obtained into analog, which can support the system. So, if you see, the aim is not so easy to understand, but if you focus, then you will understand that what we want to control and maintain the speed of the DC motor, and then we have RPM measurement with a help of encoders. However, the encoders are digital, and that is why we require signal conditioning circuit to convert the frequency of pulses into analog, which can support the system. Okay. Now, the control action needed to bring and maintain the speed of the motor to the desired set point would be obtained by designing a basic controllers with the objective of minimizing error. So, what are our objectives? There are few objectives. The first one is to implement a circuit for converting the digital pulses from encoder to analog variable signal, because the encoders are giving us output in form of digital signals. To implement a controller to maintain the temperature of transistor to require the set point. So, there are two objectives that you see here, and for that what we will do, we will see the block diagram of the closed loop control system. Again this experiment will be taken care of by the TA, but let us quickly see the theory part of it. So, if you see the block diagram of the closed loop control system, you can see that there is a system input and there is a error detector which detects the error with the help of the feedback signal, which is our sensor and signal conditioning circuit. We have a controller to control and the speed of the DC motor, and whatever the system output is there is feedback with the signal conditioning circuit back to the error detector. Whatever the errors are there, it will be taken care of, and according to that the controller can maintain the speed of the DC motor. So, we will discuss this thing in detail. The role of error detector here is to produce an error signal, which is a difference of the system input, which is here, and the feedback signal, which is from the sensor and signal conditioning circuit. This feedback signal is obtained from the block, which is we have shown sensor and signal. So, now when we talk about signal conditioning circuit, we also have to understand sensors, and that is why if you remember we have taken a topic on why sensors are important, how you can design sensor, how you can fabricate those sensors, right. So, sensors are very important, and then once you have sensor, the sensing data can be further you can do the acquisition of that, and you can control that, you can do the signal conditioning that with the help of the operation amplifiers and relevant components. So, instead of by direct input, the error signal is applied as an input to the controller. Finally, what is the role of controller? Controller produces an actuating signal which controls the plant, right. So, plant or DC motor, that is one and the same thing. In this combination, the output of the control system is adjusted automatically till we get the desired response. Hence, the closed loop control system are also called automatic control systems. Okay. So, this is a closed loop control system. Finally, there is a two more thing that we need to understand, which is implementation of error detection, which measures the difference between input and the feedback signal. And error amplifier experimental procedure is, if you see this particular circuit, then we need to connect V1 and V2 to the inputs of error amplifier, and R1 and R3 are resistors shown in figure, right, which are of 100K. So, what we have to do? We have to measure the output VO. Alright, and this is a common mode operation. So, calculate common mode gain. You already know how to calculate common mode gain, because we have seen the operational amplifier parameters in our starting of the this particular course, and then what we have to do? We have to connect V1 to the input and V2 to the signal low and measure the output. This is a differential mode operation, so you can have differential mode gain. Now, if you have common mode gain, if you have the differential mode gain, what you can find? You can find common mode rejection ratio. Right, that is what we have to do in this experiment. Again, we will discuss about experiment in detail in the experimental class. If you want to design a driver circuit for DC motor, it is a DC motor, a driver circuit, then we can use the following circuit which is here, right, and the op amp voltage is applied to a power transistor, which you can see here, right. The op amp compares the motor voltage to the input at the non inverting terminal, right. This is at the non inverting terminal. The input is applied to the non inverting terminal, and here we have inverting terminal which is compared. So, the net effect is that motor is kept at the same level of the positive terminal. Note that the motor speed varies not only with the voltage, but with the load as well. If we change the voltage, the speed varies. If we change the load, the speed will vary. So, even though the motor voltage is kept constant, the motor speed may not. So, how can we do the experiments? We can connect the circuit as shown in figure, and then if we apply a DC voltage of 0.5 volts at point V1 and slowly increase the voltage with a step of 0.5 volts, then what we can find? We can find the change in the current of the motor and the rotations of the motor, and then we can calculate the relation between output RPM and the input voltage. Right. So, we will see these details in the circuit. This is the last slide for this particular lecture, and the TA will show it to you the experiment that we have designed for controlling the DC motor. So, just go through this particular slides, ask any question if you have any doubts through forum, and we will be very happy to answer your questions. Till then, you take care, have fun, bye.